Hello everyone, good evening. My name is Vishwadeep and I welcome you all on Unacademy's Computer Science Channel for unlimited learning. In today's lecture, we are going to discuss few more things about pipelining which we started yesterday, and then we are talking about this synchronous pipeline today more specifically, and then we are going to solve some questions on the pipeline processing. Okay, so without any delay, let's get started. Before I go further, let me introduce myself for all of you people. My name is Vishwadeep. I have written GATE multiple times. Among those, this is my best rank till the date in my final year. In the third year, I was able to score 682. Apart from that, I have written GATE with rank 440, 119, and there are a few more ranks out there. I went for my masters into ISC Bangalore. Then another MTech I have completed from BITS Pilani in data science to learn the current trending technologies, which is the data science, machine learning and all. I am having a rich experience of teaching 13 years overall and 9 years in GATE ESE. These are the courses I teach: computer organization architecture, which you are of course listening here, data structure also I teach, and some coding interview preparation also I conduct. Apart from these, I have taught OS and compiler design also before. Now I am going to talk about very specific thing for you guys. Is this key? This is not only the source where you can learn for free. Yes, my friends, YouTube is not the only source where we teach for free. Here is another source which we teach it at for free is unacademy.com or on Unacademy Learner app. Yes, you go there, you search my name Vishwadeep, and then you follow my profile here. There, what you will be getting over there is there are so many special classes. जी हाँ दोस्तों, बहुत सारी special classes मिलेंगी आपको, which I have already taken. Those are in the recorded mode. You can learn, you can watch those for free. Apart from that, I take daily live classes at 10 a.m. Yes, now the timing has been changed, 10 a.m. Right now, I am going for revision of 10 a.m. or revision of COA in the 10 a.m. special classes. So you can join, you can learn in the revision mode also. So revision of the COA I am conducting at 10 a.m. on special classes unacademy.com or Unacademy's Learner app for free. Yes, my friends, for free. So you can come, you can join live over there. Apart from that, if you are serious about your preparation, if you want that your rank should be perfect, then you need to join Unacademy Plus. What are the benefits of Unacademy Plus? I'll tell you first that we will be conducting live classes over there, which you can of course listen in the recorded mode also if you miss any, or if you want to learn again the same concept. The structured schedule will be there. You will be studying in a batch kind of an environment, hence your learning will be better, the environment will be better, the discussion will be better, and hence your rank should be better. There will be test series from Unacademy. Yes, for free. Of course, it will be included in Plus subscription. Then we will be providing you unlimited practice. Then we will be providing you all-time doubt facility also. So personally, we used to solve the doubts. Then after that, we used to solve the doubts during the classroom also. We used to solve the doubt in very special doubt sessions, which we conduct after every 3 classes. So we will be solving all those doubts anyway for you guys, and that comes in Unacademy Plus subscription, and that particular subscription you can get if you will be using the code VDEEP10, and in that you will be getting the 10% discount. Yes, you can get that particular subscription done using the code VDEEP10 and you will be getting 10% discount. Right, another subscription option we have in which there will be a one-to-one personal coach for you. There will be some person who will be planning for your study. There will be a person who will be giving you expert guidance. Then time to time that fellow will be tracking your performance so that you will be having always your problem rectified within 1 week or maximum 2 weeks, and that particular personal coach will be coming under iconic subscription for your iconic rank, and that iconic subscription also you can get after the discount of using code VDEEP10. 10% discount you will be getting. after using this code, but that code is not only the code for subscription of the 10% discount. That particular code will unlock my mentorship. As you have already seen, I have cracked the gate multiple times. Then I'm teaching since long, so I know in and out how to prepare for gate. So my mentorship you can get. Plus we are having a team, entire team support you will be getting in your doubts, in your preparation, whatever the subject you are facing the problem, entire team which is going to prepare, which is going to teach you, entire team will help you in that particular case. And where the team is here, boss. My name Vishwadeep Malesham sir, Deva sir, he is one of the greatest in the entire country for TOC and compiler and C language. Satish Yadav sir, one of the best of the country for discrete math. Khalil sir, 10 plus experience only of teaching operating system. Pankaj sir, 9 years experience on teaching computer network. So entire team, and we are expanding the team, there will be so many other members also. If you want to join the Unacademy Plus, just now at 8th of September only we started a new batch, and yesterday only I have started a new course called as multi-purpose comprehensive course on data structure. You can check it out. You can check it out with all those members who are on Unacademy Plus. They can review this particular course. Only 2 lectures I have taken till now, but the students are having faith that I can definitely help them in their coding improvement, which I claim. Yes, increase your interest in coding. Definitely you will increase if you will attend this particular course on Unacademy Plus. Plus definitely it will help you in GATE exam. Okay, and then there are so many other specialties of the courses there that started yesterday. If you want to be the part of the course, you want to learn live, you want to solve so many good problems in data structure, to be placed in a coding based interview, to be placed into the good company like Amazon or Microsoft something, then you need to join Unacademy Plus, and there you need to use the code VDEEP10. If you are really interested in learning, definitely you should come for that particular course. And here it is, the first page of my class. Always remember, सबको पता है what exactly happens. I used to ask you, are you ready? अब मैं लिखूंगा नहीं. I used to write down previously, but today I have brought this particular are you ready page there. Now let's have a recap. What we studied till now. What we studied till now is the pipelining. Where we apply the pipelining? We apply the pipelining when we have same processing applied over multiple inputs. That was my first statement. Then in the pipelining, we divide the entire processing into small sub-operations. These sub-operations are performed in the segments or stages, and then we have seen further few more details of the pipeline, ki how exactly pipeline works, and then based on that we have calculated that the pipeline takes time is equal to k plus n minus 1 into TP for n number of operations. TP is the cycle time, k is the number of segments, n is number of operations to be performed or number of inputs to be processed. Then we have calculated the speed up, which is non-pipeline time NTN divided by total pipeline time k plus n minus 1 into TP. After that we have gone for speed up maximum, which was the ideal speed up, that is Tn by Tp. In a very specific case I told कि this S max will become K. इतना कल तक हमने पढ़ा. अब आगे look at this synchronous pipeline. What synchronous pipeline says? What synchronous pipeline says? Synchronous pipeline says कि suppose if you are having different segments, suppose this is one hardware performing some operation, this is another hardware performing some operation, another hardware performing some operation, another hardware performing some operation, it might possible that all these hardwares may take different delay, different time for their respective sub operation. Possible है? जी हाँ possible है. एक में एडर है, एक में मल्टीप्लायर है. If you have one segment with adder, one segment with multiplier, of course the time of these operations may vary. So if we have segments like this and the time is different, then we need to synchronize all the segments. segments. So what we will do, we will not start each segment का सब ऑपरेशन रैंडमली कभी भी कि अच्छा सेगमेंट नंबर 2 का अपना काम खत्म हो गया तो मैं अपने हिसाब से अगला काम करूंगा, ऐसा नहीं करेंगे. We will synchronize all these pipeline segments externally by using same clock. एक clock generator हम use करेंगे and then using that clock generator we will synchronize all these pipeline stages. And how you will do? किस speed पे हम ये करें? The speed will be based on different delay. So suppose S1 taking internal delay of 10 nanoseconds to perform the operation. This takes 12 nanosecond, this takes 8 nanosecond, and this takes suppose 9 nanosecond. Then ऐसा क्या time choose करोगे so that all segments can perform their respective task? In that case, up cycle time will be chosen as the maximum of all these segments. Maximum of segment delays you are going to choose so that what happens, all these segments can perform complete operation in that cycle, and cycle time we denote by TP. तो आपको TP ऐसे choose करना है so that you can finish your entire operation. Okay, so TP in this particular case I'll be choosing maximum of 10, 12, 8, 9, which will be equal to 12. But you know what happens if different segments are taking different time. In that particular case, it might possible, हो सकता है ऐसा कि आपका जो सेगमेंट का इंटरमीडिएट वैल्यू है that may lost somewhere. This segment is generating some output, that output goes into segment number 2, तभी तो वो आगे प्रोसेस होगा. इसने शर्ट को कट कर दिया, वो शर्ट अब यहाँ पे स्टिच होगी तो वो शर्ट यहाँ S1 से आएगी ना. If you remember my yesterday's example. So if S1 has performed some operation, then its output will be used as input in S2. Yes. Then what happens in that particular case? In that particular case, I will need some kind of storage unit in between these. तो हम synchronous pipeline को और efficient बनाने के लिए we put some extra buffer or registers. So whatever the red color डब्बे, red color boxes you can see, all these are nothing but intermediate buffer or register. Intermediate buffer or register. So intermediate register or intermediate buffer are used so that the synchronization can be proper. So what happens at the end of cycle, first cycle, S1, at the end of any cycle, S1 will provide its output in this register, S2 will provide its output in this register, S3 will provide in this, and S4 will provide in this. In the next cycle's initiation means जब नई cycle start होती है, at the starting of the next cycle, S2 will take input from here, S3 will take input from here, S4 will take input from here. इस तरीके से दोनों सारे के सारे segments synchronized रहते हैं. In this particular case, this segment and this intermediate register will be making my one segment. तो मेरा एक segment जो होगा वो इस type का होगा, इतना बड़ा. Just because of course this will also add some extra delay. इसका भी तो time लगेगा. अरे इसका time लगेगा या नहीं लगेगा? Yes. So in that particular case, if I want to choose the value of TP, it will be equal to maximum of segment delays plus register delay. That will be your what? That will be your TP time. So in this particular case, just assume करते हैं, let's assume that S1 takes same 10 nanosecond time, this takes 12 nanosecond time, this takes 8 nanoseconds time, and this takes 9 nanosecond time, and all these registers are taking 2 nanoseconds each. Then what will be the TP time I'll be selecting? TP time I'll be selecting is maximum of segment delays, which is maximum of 10, 12, 8, 9 plus register delay 2, answer will be 14 nanoseconds. अब एक क्वेश्चन सिंपल सा आपको पूछता हूं कि ये सिंक्रोनाइजेशन की जरूरत सिर्फ पाइपलाइन में लगेगी? यस, दिस सिंक्रोनाइजेशन इज नीडेड ओनली इन पाइपलाइन. इफ यू विल कंपेयर दिस पाइपलाइन विद corresponding non pipeline system, then in non pipeline system no any need of intermediate buffer, no any need of intermediate buffer or register. So if somebody asks you can you calculate one task performance time in a non pipeline system, TN, कितना टाइम लगेगा? So first of all, first input will be processed in S1, 10 nanosecond. After that, no register, only S2 next, 12 nanosecond for next operation, 8 nanosecond for next operation, 9 nanosecond for next operation. It will be nothing but summation of all segment delays. पर ये किया क्यों ऐसा? मुझे TN मतलब क्या है? TN is nothing but one task performance time in a non pipeline system. एक इनपुट को नॉन पाइपलाइन सिस्टम में प्रोसेस करने में कितना टाइम लगेगा, S1 से लेके S4 तक का सबका डिले ऐड कर दो, इतना टोटल टाइम लगेगा. सो इफ इतना टोटल टाइम लगेगा, कितना हो जाएगा ये? इट विल बी 10 प्लस 12 प्लस 8 प्लस 9, 39 nanoseconds. Remember, these intermediate buffers are used only in pipeline, not in the non-pipeline system. ठीक है, चलिए, okay, great. 38 आएगा, 39 आएगा. Fine, okay, good. If you are clear about this, if you are fine with this, let's go further and let's try to understand cycle time in synchronous pipeline. मैंने लिख दिया है already, but for your formula purpose, I am writing it again. Maximum of segment delays plus what? Plus what? Intermediate register delay. And here TN you will be choosing as what? TN you will be choosing as what? Sum of all segment delay. SEG का मतलब होता है सेगमेंट भैया, ठीक है? Okay, fine. Now let's try to understand what is the latency and what is the throughput. But before that, I want to tell you one small information. एक छोटी सी information मैं यहाँ आपको देना चाहता हूँ कि if a question is given and in the question if speed up is asked, then which formula you are going to use? The normal formula or the ideal case formula? अगर question में mention नहीं है कि best or the maximum or the ideal condition speed up you will have to calculate. So speed up formula you are going to use based on if a value of n is given or not. याद रखें, it's very simple. Then very simple concept है, if value of number of tasks given, n is given, number of instructions or number of inputs or number of tasks given, then speed up you will be calculating by this one only, n into Tn divide by k plus n minus 1 into Tp. And if value of n not given, then you are going to go for speed up S max, which is Tn by Tp. Of course, you need to read the question carefully, if they are asking directly maximum speed or not, or if they are asking directly ideal case speed up or not. If directly asking ideal case speed up, you will be going directly this. If nothing is asked, only speed up is asked, you need to check if n value given this one, if not given this one. याद रखें, बहुत अच्छी बात है, बहुत सिंपल सी बात है. यू कैन रिमेंबर, यहाँ पे n की वैल्यू यूज हो रही है, यहाँ नहीं. बहुत सारे स्टूडेंट ऐसे बोलते हैं सर n की वैल्यू 100 मान के कर दे चलेगा. अरे नहीं चलेगा, नहीं चलेगा बाबा, नहीं चलेगा, नहीं चलेगा. क्यों? जस्ट बिकॉज फॉर एवरी डिफरेंट वैल्यू ऑफ n स्पीड अप विल बी डिफरेंट. आप n की वैल्यू 100 रखो, स्पीड कुछ अलग आएगी. n की वैल्यू 200 रखो, स्पीड अप विल बी डिफरेंट. n वैल्यू 300, स्पीड अप विल बी डिफरेंट. So it's very simple thing. If n value given, then only you use this formula, otherwise directly use for maximum formula. Okay, remember this. Now let's talk about latency and throughput. पहले बात करते हैं latency. Let's talk about latency. What is latency? Latency is the time after which your machine takes next input. After how much time your machine will take next input. अच्छा, एक सिंपल सी बात बताएं. What is non pipeline or sequential processor? First you give an input. That input will be processed completely. You will get the output. After that you will give the next input. पूरा इनपुट प्रोसेस होने के बाद ही नया इनपुट दोगे. यस, हाउ मच टाइम? कितने टाइम के बाद नया इनपुट दिया? एग्जैक्टली उतने टाइम के बाद जितना कि पहला इनपुट को प्रोसेस करने में टाइम लगा. After how much time you will be giving the next input, as much as time required by your machine to process one particular operation in non-pipeline system. So if I am talking about latency in non-pipeline system, कितना होगा? क्या मैं TN टाइम लिख सकता हूं? अरे सिंपल सी बात है. आफ्टर हाउ मच टाइम यू आर प्रोसेसिंग और यू आर प्रोवाइडिंग नेक्स्ट इनपुट. आफ्टर दिस मच टाइम, इतने टाइम में एक इनपुट प्रोसेस हुआ, इसके बाद ही नया इनपुट दिया जाएगा मशीन. राइट? इफ यू आर क्लियर अबाउट दिस, देन कैन यू टेल मी latency in the pipeline system will be what? After how much time you provide the next input in the pipeline, वो होता है after one cycle we are providing next input in the pipeline which is TP time. अगर आपको कल का मेरा एग्जाम्पल याद है, I have given that in the first cycle, first input will be processed here. In the second cycle, this input will be coming here and another input comes here in the first segment. So after how much time from here to here, after how much time you have provided next input in the pipeline, that is one cycle. After each cycle you are providing next input, means TP time you are providing the next input, that is the latency. क्या clear है सब लोगों को ये चीज? If you guys are clear about this, then I'll be going with this throughput. If you are clear about this, then हम बात करेंगे throughput की. Simple. Okay, so throughput is what? Throughput is the performance in per unit of time. In per unit of time, throughput is nothing but number of inputs processed per unit of time. So ये है latency, ये है throughput, right? If you remember, I told you कि n number of elements को process करने के लिए how much time your pipeline takes? This much time. Pipeline time for n number of processes or n number of inputs is this. अगर n number of inputs के लिए this much time, then in one time unit how many number of processes or how many number of inputs can be processed? So or I should say in this much time n number of inputs are processed, then in one time unit how many number of inputs are processed, then in the regular cases the throughput will be like this: n number of inputs are processed divided by k plus n minus 1 into TP time, this much time. That will be the throughput in the regular cases. क्या आप सहमत हैं इस चीज से? आर यू एग्री विथ दिस पॉइंट? अगर नहीं है तो मैं आपको समझाता हूं अगले पेज पे. यू नो कि इन द टाइम k plus n minus 1 into TP time, how many number of inputs are processed? which is equal to n number of inputs are processed, then in 1 unit of time कितना input process हो जाएगा? बताओ भैया बताओ. ये वही तो मैंने वहां लिखा. अब ये ऐसे सिंस एंड देन करके चुंकी उंकी लिख के और ऐसे बनाएंगे तो आपको समझ में आएगा हर बार. अरे आप इंजीनियर हो यार, स्मार्ट हो, यू कैन अंडरस्टैंड इट वेरी क्विकली, वेरी इजीली, राइट. सो दिस इज द थ्रूपुट बॉस, रेगुलर थ्रूपुट, but if I am going with the ideal condition, ideal case. In ideal case, yesterday I explained you कि k-1 you will have to ignore. K-1 you will have to ignore for n number of inputs, n number of cycles are required, means n into tp time required. So in the ideal case, if n into tp time required for n number of inputs in one time, how much? N divided by ये k-1 ignore करेंगे, n divided by n into tp means 1 by tp. So in ideal case, the throughput will become what? मैंने हवा में बहुत कुछ समझा दिया, तुमको हवा में समझ में आया कि नहीं आया? जल्दी से टाइप करके बताओ. Throughput will be 1 by TP in the ideal case when the number of inputs are not given, or in the ideal case they have asked for. So throughput will be 1 divided by TP in ideal cases. Why? k-1 ignore करेंगे, n divided by ntp, 1 divided by tp. Very simple. So if I don't know what is the value of n, or if I know कि ideal case throughput I'll have to calculate this much. समझ में आया? नहीं आया? टाइप करो जल्दी से. Type down boss, type down so that I can understand कि you understood or not. तुम्हारा समझना जरूरी है. मैंने एग्जाम लिखा हुआ है, बहुत बार अच्छी रैंक भी लाया है. तुमको रैंक लाना है अब, so you need to understand it better. If you can, then well and good. If you don't, then definitely problem. Now listen, consider a 5-stage pipeline. अब क्वेश्चन सॉल्व करते हैं. डीपीपी मैंने लिखा था, जल्दी जल्दी you also solve, I'll also solve. Consider a 5-stage pipeline with cycle time 15 nanosecond. Calculate processing time of pipeline for 500 tasks. So pipeline takes how much time for 500 tasks? So n is equal to 500, k is equal to 5, number of segments, cycle time tp is equal to 15. We know for 500 tasks how much time will be required. Time will be equal to k plus n minus 1 into tp. That's the cycle time or the pipeline time. K is what? K is 5 plus 500 minus 1 into tp. What is tp? 15. जल्दी से सॉल्व करके बताओ, which is 504 into 15. This much nanosecond required for 500 number of tasks. Good Pratik, nice, super. Okay, next question, question number 2. This was the warm up. धीरे धीरे करके और अच्छे क्वेश्चन आएंगे. So stay with me and learn and solve. You need to solve the question before me रे buddy. चलिए, another question. Consider 6 segment pipeline with segment delay of these 20, 26, 21, 21, 24, 28. Calculate processing time of pipeline with 1000 task. अब थोड़ा सा TP time choose करने का अलग क्वेश्चन हो गया है. ठीक है. Okay, so consider 6 segment pipeline. K is equal to 6. Now I'll have to calculate TP. TP is equal to maximum of segment delay, means maximum of 20, 26, 21, 21, 24, 28, which is equal to 28. Is there any other delay given? No, means register delay ignored, 0 ले लो. Then n is equal to 1000 number of tasks. Right? Now, if n is equal to this one, TP this one, K6, then total time will be equal to K plus n minus 1 into TP, which is equal to how much? Is equal to 6 plus 1000 minus 1 into 28, which is 1005 into 28. 1005 into 28. मैं भी कोशिश करूंगा, ऐसे नहीं है, मैं तुम्हारे पे नहीं मानूंगा. 28,140 I am getting. 28,140 nanosecond. Good, good, good. If you are able to get the correct answer same to same, well and good. Super. बहुत easy question है, warm up questions है. These are the warm up questions. अरे 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 28,140, 1005 into 28. Fine. If you are done with this, let's go. Next question is, in above question, calculate the speed up of pipeline as compared to respective non-pipeline system. So in this particular case, this is the pipeline time. What will be the non-pipeline time? Non-pipeline time will be what? Non-pipeline time for one task is equal to Tn, which we will take as summation of all the segment delays. Summation is 20 plus 26, 20 plus 26 plus 21 two times plus 24 and 28. 24 plus 28. जल्दी से कैलकुलेट करो कितना आ रहा है. Calculate it quickly. I am getting 140. That is for one task. Tn is 140, and hence speed up will be what? Number of tasks given here. Yes, n is equal to 1000. In that particular case, it will be ntn, which is 1000 into 140 divided by this time which we have calculated, 28,140. Calculate it. Calculate it. Calculate it. Quickly, 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 quickly. I am also calculating. I am also calculating. You also calculate. 140 divided by 28,140. So I am getting some 4.97 or 9, almost 98. Can you give me the same answer? Yes, okay, Piyush, exactly. 4.98 something. Can you tell me what is the maximum speed up we can achieve here? Can you tell me maximum speed up can be how much? जल्दी से ये भी करके बताओ NJ. जल्दी से ये भी करके बताओ. Maximum speed up can be how much? Tn by Tp. Tn by Tp. Tn is how much? 140 divided by Tp. How much? 28. 140 divided by 120. 28. जल्दी से 140 divided by 28. It will be 5. So maximum speed up will be equal to 5. Good if you are able to solve these questions till this level. Good, 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 good. Okay, okay, that's great, that's great, that's great. चलिए, अगर आप लोगों से इतना हो रहा है तो और आगे बढ़ते हैं. क्वेश्चन नंबर 3 बड़ा सिंपल सा है, सेम टू सेम टाइप का है. फटाफट फटाफट एक प्रैक्टिस हो जाए यार. नॉन पाइपलाइन सिस्टम which takes 100 nanoseconds to perform a task. Same task can be performed in 6 segment pipeline with cycle time 19. Calculate speed up for 100,000 tasks and maximum speed up. Okay, warm up question again. Quickly. So, non-pipeline takes 100 nanosecond, means Tn time given 100 nanoseconds. Okay, then 6 segment pipeline, K is equal to 6, pipeline time 19 nanosecond. Then for n equals to 1000 number of tasks, how much speed up is there? So it will be equal to n 1000 into Tn 100 divided by K plus n minus 1 into Tp. Calculate करो जल्दी से कितना आ रहा है. Quickly. I'm getting 5.23. Are you also getting the same or not? 5.23 I'm getting. Yes, 5 point something, 5.23. And then second one, this was the first one, second one. Second one, maximum speed up. Calculate करो जल्दी से. Which is Tn by Tp. बहुत आसान होगा ये तो यार. Tn is 100 divided by Tp 19. How much it will be? Maximum speed up will be how much? 100 divided by 19, 5.26, not too far away. So for 1000 number of operations, the speed up and the maximum speed up both are not too far away. ज़्यादा दूर नहीं है हम हमारे speed up से, maximum से. So as much as you will increase the number of tasks, maybe 2000, 5000, maybe more than that, 10,000, 1 lakh, 2 lakh, 10 to the power 6, 7, 8, then it will be almost maximum. तभी तो हम वो condition रखते हैं. ठीक है. Okay, these are just the calculation question. Now this is one of the gate question which is based on the same concept which we have learned. Consider an instruction pipeline with 4 stages, these, each with combinational circuit only. The pipeline registers are required between each stage and the end of the last stage like this. So this is stage register, stage register, stage register, stage register. The delays of these are given as this 5, 6, 11 and 8, and in between 1 nanosecond ka pipeline register. What is the approximate speed of the pipeline in steady state under ideal condition? ये देखिए ideal condition word लिखा है means Tn by Tp. So let's calculate Tp first from here. What is Tp? Maximum of segment delay. Maximum of segment delay is what? चलिए एक काम करते हैं, इसका आंसर मैं नेक्स्ट पेज पे लिख लेता हूँ. So maximum of segment delay is what? Maximum of segment delays are 5, 6, 11 and 8. So 5, 6, 11 and 8 plus register delay which is 1 nanosecond. Maximum of these 11 plus 1 total 12 nanosecond. And then at the end Tn time will be the summation of all segment delays, which is 5 plus 6 plus 11 plus 8. So 5 plus 6 plus 11 plus 8. Answer will be how much? 19 and 11, 30 nanoseconds. So what will be the speed up in the ideal condition? मेरे को इसको आइडियल लिखना चाहिए, ज़्यादा सही रहेगा. इन द आइडियल कंडीशन स्पीड अप विल बी इक्वल टू 30 Tn डिवाइड बाय Tp12. आंसर इज 2.5. देखिए कितना आसान क्वेश्चन है बॉस. अगर आप लोग ये क्वेश्चन सॉल्व करोगे, इतना आसान क्वेश्चन, इतना बड़ा रीड करो एंड इट विल बी टेकिंग हार्डली 30 seconds टू गेट द आंसर. So if you understand the concept, if you remember the concept, आपके लिए बहुत आसान हो जाएगा क्वेश्चन सॉल्व करना in the exam. Few more questions. I am having another question of 2015 gate. Consider a non-pipelined processor with a clock rate of 2.5 gigahertz. So if clock rate is this much, can you tell me what is the cycle time in the non-pipeline system? Cycle time in non-pipeline system. अरे आपको पता है साइकिल टाइम विल बी नथिंग बट रिवर्स ऑफ द this frequency. 1 divided by 2.5 is 0.4 gigahertz will go up and becomes nanosecond. कैसे किया? Giga is 10 to the power 9 goes up 10 to the power minus 9, hertz go up becomes nanoseconds. 0.4 nanosecond. And average cycles per instruction of 4 means CPI is given is equal to 4. So can you tell me one instruction execution time or one task performance time in the non-pipeline system will be equal to what? For non-pipeline system only I am calculating here. तो एक पूरे ऑपरेशन को परफॉर्म करने में टाइम लगेगा 4 cycles of 0.4 each, which is 1.6 nanosecond, and this is nothing but we have our Tn time. The same processor is upgraded to pipelined processor with 5 stages, means K is equal to 5. But due to internal pipeline delay, the clock speed is reduced to 2 gigahertz. किसी वजह से आपके पास clock speed इतनी आ गई है. So in that particular case, TP, cycle time of pipeline, will be 1 by 2 gigahertz, which is nothing but 0.5 nanosecond. That is nothing but cycle time in pipeline. Okay, now if no any stall in the pipeline, क्या होता है stall आपको अगर नहीं पता है, it's okay, छोड़ दो. The speed up achieved in the pipeline processor is how much? कितनी speed up हो सकती है? N की value given है. The value of number of operations given? No. If not given, then speed up you will be taking as Tn by Tp. Simple सी बात है boss. अगर आपको n की वैल्यू नहीं गिवन है, if n value is not given, directly you can go for what? Directly you can go for Tn by Tp, which is 1.6 divided by 0.5. Answer is 3.2. 3.2 is the speed up. Very simple, very simple. Good, Pradeep. Nice engine. Good going. Nice. Okay, so this is the way you can solve the question. अब और थोड़ी डिटेल में और थोड़ी चीजों के बारे में बात करते हैं. फाइन. ओके, नाउ आई विल बी टेलिंग यू फ्यू मोर information before I will be going for the questions or something. Now listen. If you say for n number of operations, the pipeline takes time is equal to this much, K plus n minus 1 into TP. Can you tell me for one operation or for one task or for one input, how much time pipeline will take on an average? On an average, how much time is taken by the pipeline? Jaldi se batao. That will be K plus n minus 1 into TP divided by n. क्या ये सही है? So that is your CPI. Per instruction or per operation, these many, or sorry, for per operation, this is the total time required. Or if you want to calculate the same thing in cycles, अगर आपको same चीज cycles में calculate करनी है, like in the CPI terms, then I can write that for one operation, the number of cycles will be how many? Number of cycles will be how many? Time हटा दो यहां से, so it will be K plus n minus 1 number of cycles for n number of operations divided by n. So this is the total time required for n operations, and for one operation this much time. If somebody asks how many number of cycles are required for n operation, K plus n minus 1, for one operation on an average, K plus n minus 1 divided by n. This you can say as my CPI, cycles per instruction or cycle per operation. Right. Same thing if I want to write in ideal cases, then in ideal condition, if I want to go for, then in ideal condition, how much it will be? In ideal condition, what will be the CPI of your pipeline? Ideal condition में K minus 1 हट जाएगा, so CPI or number of cycles will be what? Cycles per operation will be what? Cycles per ऑपरेशन विल बी इक्वल टू 1. ये तो हम कल ही प्रूव कर चुके हैं, आज मैंने लिख भी दिया. K minus 1 हटा दो, n डिवाइड बाय n 1. एंड टाइम पर ऑपरेशन विल बी हाउ मच? Will be equal to how much? 1 साइकिल, एक साइकिल का टाइम टीपी टाइम। कुछ छोटी छोटी चीजें हैं जो आप खुद से भी कर सकते थे, बट मैंने यहां बता दिया, आपको और अच्छे से समझ में आ जाएगा। So small things are there which you can even understand in more detail if somebody explain you in like this way. Fine. Another question. The stage delays. Another gate question it is. 4-stage pipeline are these picoseconds. The first stage delay, this is replaced with a functionally equivalent design involving 2 stages with respective delays this and this. The throughput increase of the pipeline is. तो पहले तो आपके पास में फर्स्ट पाइपलाइन है, आई एम अज्यूमिंग P1 पाइपलाइन, उसमें डिलेज कितना है 800, 500, 400, 300 and k is equal to 4. Then after that you have upgraded this into pipeline number 2, in that you have this first segment divided into 2, ये दो में डिवाइड किया, which are 600, 350, remaining 3 are same to same 500, 400 and 300. अब बताओ नंबर ऑफ सेगमेंट्स कितने हो गए 5. Now tell me, if I want to choose TP from here, what will be the TP? TP will be here is maximum of all the segment delays, which is 800, 500, 400 and 300. Right, which is nothing but 800 picoseconds. And here if I want to calculate TP time, it will be equal to how much? Maximum of all these 600 plus 350 plus 500 plus 400 plus 300, which is 600 picoseconds. अभी पूछा है थ्रूपुट में इंक्रीज, तो पहले तो थ्रूपुट निकालेंगे. सो व्हाट इज द थ्रूपुट? इफ थ्रूपुट we will have to calculate what is the throughput. अभी बताया मैंने, ये रहा, कहां गया, ये रहा throughput. Okay, so if number of n is given, then this. If not given, then 1 by TP. Number of operations given, then this is the throughput. If not, then 1 by TP. In this particular question, there is no any throughput or no any value of n given. Then in that case, it will be 1 divided by TP. Right? So for throughput for pipeline P1, throughput will be equal to how much? 1 divided by 800. And for pipeline number 2, it will be 1 divided by 600. बताओ कौन सी वैल्यू ज्यादा, ये कि ये? आप बोलोगे ये कि ये वाली. अरे ज्यादा नंबर तो यहाँ पे, बड़ा तो यहाँ पे. अरे डाउन साइड है रे बाबू. मैथमेटिक्स समझ में आता है आप लोगों को, सबको. यू आर इंटेलिजेंट. दिस इज लार्जर. सो फ्रॉम हियर टू हियर थ्रूपुट इंक्रीज्ड. यस, हाउ मच? So throughput increase is this much minus this much. इतना increase हुआ as compared to the older value, this one, into percentage. That is the percentage of throughput increase, and that is how much. कैलकुलेट करते हैं, ये 800 ऊपर ले जाके मल्टीप्लाई कर देते हैं. सो इट विल बी 8 by 6 minus 1 into 100%, which is nothing but 4 by 3 minus 1 is 1 by 3, 33.3% I am getting. 33.33% I am getting as the throughput increase from here to here. So that was the question. How much percentage? Which is 33.3. सिंपल, बिल्कुल सिंपल. अरे सिंपल कर लेना यार इसको. 1.33 minus 33 आ जाएगा. Okay. If you are done with this, there are so many such kind of problems you will be facing in your examination or in your test series which you will be able to solve easily. एक और क्वेश्चन बचा है, but before that I want to show you our schedule. One more question is remaining. Before that I want to show you the simple schedule which we are following as of now. 11 a.m. we are having computer network on the same channel, TOC 4:30 p.m. by Malesham sir. My class is 5:30 p.m. daily, Satish Yadav sir, discrete math. And tomorrow I am going to teach the most complicated thing in this particular pipeline chapter is instruction pipeline. I am going to start it and I am going to explain you how exactly instruction pipeline works and its multiple small things you will have to present here if you are really interested in learning instruction pipeline. तो अगर आप लोग चाहते हैं instruction pipeline पढ़ना, come live. I will make sure कि your session will be amazing. अगर आप लोग को समझ में नहीं आएगा, डेफिनेटली यू कैन आस्क मी कि सर नहीं समझ में आया या एक्चुअली पसंद नहीं आया, बट डेफिनेटली आई कैन मेक श्योर इन दैट पर्टिकुलर केस कि यू विल लव दैट सेशन. Definitely you are going to learn that and you are going to love it. Okay, another question I am having. 6-segment pipeline. Okay. 6-segment pipeline, P1 with segment delays this respectively. This pipeline is upgraded to another pipeline P2 with 8 segment, in each segment 2 nanosecond. For 100 data items, how much time can be saved in P2 over P1? तो दो अलग अलग पाइपलाइंस गिवन है, P1 एंड P2. पहले अलग अलग के दोनों सब कुछ लिख लेते हैं जो गिवन है. Let's see what is given. 6-segment pipeline, these are the segment delays. So segment delay are 3, 5, 4, then 7, 8 and 6. K is equal to 6. In that case, TP क्या होगा? Maximum of these will be 8 nanosecond. P2 upgraded to K equals to 6 or sorry 8 and all segments are taking 2 nanosecond. 2, 2, 3, 4, 5, 6, 7, 8. All are taking 2. What is the maximum of that? TP क्या चूज करेंगे? इन सब का मैक्सिमम. मैं थोड़ा जल्दी कर रहा हूं क्योंकि मुझे ऐसा लगता है आपको समझ में आ रही होंगी चीजें. इफ यू डोंट गेट इट, कमेंट में लिखो सर थोड़ा स्लो पढ़ाओ, मैं वो भी कर दूंगा. हर चीज लिखाओ, वो भी लिख दूंगा. सो टीपी मैक्सिमम ऑफ ऑल विच इज 2 नैनोसेकेंड हियर. व्हाट इज द क्वेश्चन? फॉर 100 डेटा आइटम्स, how much time is saved in P2 over P1? So for 100 data items, let's calculate time. So time taken in P1 for n equals to 200 is equal to how much? K 6 segment plus n 200 minus 1 into TP time 8 nanoseconds. करके बताओ कितना आ रहा है? How much it is? 205 into 8 1640 nanosecond. The same time we are going to calculate in pipeline P2 also for n equals to 200. Let's calculate that, which is equal to K 8 segments we have here plus 200 minus 1 into segment delay is this much. आपके पास TP कितना है? 2 nanosecond. In that particular case, it will be 207 into 2. Answer is 414 nanosecond. अब बताओ इसमें से इसमें कितना टाइम सेव कर लिया? How much time you have saved from here to here? कितना? 200 ही है ना? 100 items. Okay, my bad. I have taken 200 items. Okay, no problem. Let's make it out clear. I have made it for 200 items. Let's clear it and let's make it as for 6 plus 100 minus 1 into 8 nanoseconds, and here's 8 segments are there. 8 plus 100 minus 1 into 2. 105 into 8. 840 nanosecond here and here 214 nanosecond. So the first question is कि फॉर डेटा आइटम 100 कितना टाइम सेव किया P2 ने ओवर P1, हाउ मच टाइम इज सेव्ड. सो फॉर फर्स्ट क्वेश्चन टाइम सेव्ड इज हाउ मच. Time saved is this minus this. 840 minus 214, 6 to 626 nanosecond. Second question says what? सेकेंड क्वेश्चन सेज स्पीड अप ऑफ P2 ओवर P1. अगर दो पाइपलाइन को भी आपने कंपेयर किया, कितना स्पीड अप कंपैरिजन है, कितना स्पीड अप डिफरेंस है इसमें और इसमें. सो स्पीड अप विल बी इक्वल टू 840 डिवाइडेड बाय 214. कैलकुलेट करो कितना आ रहा है. 3.9. For 100 operations or for 100 data items, this is the speed up we could achieve using the pipeline number 2 over pipeline number 1. And third question says you need to calculate the maximum speed up. आपको maximum speed up पता है, cycle time above divided by cycle time below. Okay, cycle time of the slower time of cycle time is 8. Here is 2. It will be 8 divided by 2. Answer is 4. ये क्वेश्चन थोड़ा स्पेशल था. Here we were calculating or we were comparing only two pipelines itself. दो पाइपलाइन को ही हम कंपेयर कर रहे हैं यहाँ पे, तो ये थोड़ा अलग टाइप का क्वेश्चन था. बट स्टिल कंसेप्ट इज सेम, राइट. टाइम कैलकुलेटेड फॉर ईच पाइपलाइन, time saved, which was very easy one. Speed up, slower technique time divided by faster technique time for 100 operation, done. Speed up in maximum speed up, which is the ideal case scenario. In that case we have calculated that 8 divided by 2. Why? Just because one cycle time here divided by one cycle time here. Very simple, very simple. ठीक है. Okay, fine. If you are done with this, then again I am repeating the same thing, boss, ki if you want to take the subscription, use the code VDEEP10 and you can get 10% ka discount. If you want, you can go for no cost EMI also using the क्रेडिट कार्ड और HDFC डेबिट कार्ड. सो नो कॉस्ट EMI का बेनिफिट क्या है, आपको कोई एक्स्ट्रा कॉस्ट पे नहीं करना है एंड देन यू विल बी पेइंग इन द इंस्टॉलमेंट्स. तो इंस्टॉलमेंट में पे करके ऑल्सो यू कैन पे इन द स्मॉल इंस्टॉलमेंट्स एंड हेंस यू विल नॉट बी बर्डन इमीडिएटली और एक्स्ट्रा कुछ भी पे नहीं करना है आपको. Okay, and this is the Facebook page. If you are not joining or if you are not the part of, become the part of this particular Facebook page, Get Aspirants MECE CSE, and this is the channel where you will be getting all the announcement plus all the PDFs. अगर आपको ये PDF चाहिए, आपको ये यहाँ इस पेज पे जाना पड़ेगा. और साथ ही साथ ये है हमारी फैमिली जो आपको रिकमेंड करना है अलग अलग दोस्तों को जो आपके अलग अलग ब्रांचेस में हैं. फॉर Creatrix is for AC electrical IN, मैकेनिकल के लिए Unacademy Gate MEPI XC, for civil this channel, for computer science current channel, SSC JE का चैनल है, फाउंडेशन इंजीनियरिंग चैनल है, तेलुगु लैंग्वेज का चैनल अलग है. This is our family. You need to recommend all these channels. If you haven't subscribed our channel, subscribe it, like the video and share the videos with all of your friends if you are liking it. अगर आपको lectures बहुत अच्छे पसंद आ रहे हैं तो प्लीज आप लोग बाद में आने के बाद जब वीडियो खत्म हो जाए तो प्लेलिस्ट के टॉप पेज पे प्लेलिस्ट के फर्स्ट वीडियो पे आप लोग कमेंट करें कि यू आर लाइकिंग द वीडियो, सो दैट सो मेनी स्टूडेंट्स whoever will be coming to the playlist, those fellows will be understanding कि yes I am teaching fine, so उनका बहुत ज़्यादा फायदा हो जाएगा after viewing those reviews and the comments. Okay, so till then again we will meet tomorrow. बहुत important topic है, don't miss the topic which is instruction pipeline. बहुत important है. You need to come live and you need to learn. There will be so many good concepts you are going to learn tomorrow. Till then, happy learning. Have a nice day. Enjoy the rest of the day with the learning. Bye everyone.